All right, here's the tutorial for social network analysis. In this tutorial, we're going to look at bipartite networks, which are networks having two different modes. So we'll be looking at we'll actually be looking at NCCU's political science department, where the blue nodes are professors and the red nodes are the topics they study. And I'll show you how to map and color these. And from this network, we can get a network of the keywords, like here. And we can also get a network of the professors. And we'll calculate clusters, like you see here. We'll also calculate centrality measures. Like you see here, some nodes are bigger than others. So I'll show you how to do all of that in this tutorial with two mode networks. So this task, let's see, the project folder is module 4, semantic networks. So when you open this up, when you unzip this file or download, you should see there's analysis, which is empty. You'll see there's two data files, raw data version 1 and version 2. I'll show you these because there are two different ways that you could enter the network data. And I want you to be able to use this code on either format. And then for the scripts, there's we'll generate node and edge lists. You see again, there's a version 1 and a version 2. These correspond to the different file formats. So I'll use version 1 initially, but I'll show you what version 2 looks like as well. And then once you've generated the nodes and edge lists, then we'll do all the network analysis is in this second script. I might have told you we needed to download R. I decided to just do it all in Python because I think it'll be more convenient. So, okay. So I'm going to start with generating the node and edge list, version 1. Two other features of this tutorial. I'll show you. We'll look at opinion translator or converter, as well as using Google Translate, because, oh, I guess I should show you the data first. So I constructed this data probably in about 30 minutes. You'll construct your own data for this assignment. So I'll show you kind of what this looks like, but this is from NCCU College of Social Science, the Political Science Department. Here's the professor name, this is their position, and these keywords I got from their home pages, from their faculty pages. So this is the faculty page for Professor Chun. And you can see here is his position, and then positions. And here are the keywords. So this is actually the data. These are actually going to be nodes in the network. So I went down the faculty pages one by one. I just opened up each faculty member's page and I copied and pasted their name, their position. I also took the URL from their homepage just for reference, and these keywords. So I put all of that data here. I just copied and pasted those keywords and the URL. So that's what this data looks like. Let me show you the second version of the data, which is the same data, but here, this is a much more, this is already a processed version of the data. So if you import the data like this, right, you notice in the network, which I closed, you notice in the network, each professor is connected, like Liu Yizhou is connected to political science, or Chen Hui is connected to political and social. Chang Qian Yigun is connected to welfare, country, immigration policies and politics, and gender. Yang Wanning is connected to gender, Congress research, and comparing politics and democracy. So you can see that the edges in this are, to construct an edge, you basically need a professor's name and a keyword. So all of the edges are going to be professor keyword pairs, and that's what we call a two mode. Let me write this down. A two mode network, or also a bipartite network. But these mean the same thing. Bipartite networks are networks with two different kinds of nodes. In this case, the second category are the keywords. Right? So the other feature of the bipartite network, rule number one, it has to have two modes, and rule number two, nodes of the same kind are not connected. In other words, the only ties in the network are, so node one, node two ties are good. There are no node one ties, and there are no node two to node two ties. So in a bipartite network, you have the two modes. The two modes are the two modes of nodes. Or the two modes or types of nodes are connected to each other. Ties also are edges, but there are no ties or edges to the nodes of the same kind, right? So that's what a bipartite network is. But from this, I'll show you how you can generate node one and node two networks. For example, right, here's a professor network and a keyword network. I'll show you those, how we can generate those later. But anyway, so this is the kind of data. So in this raw data for Professor Chun here, this data actually contains 4 ties, right? We need Professor Chun to this first keyword, right? So let me just. So if this is Professor Chun, and then these are his 4 keywords. In this data, in the raw data, you can see we've broken down those 4 keywords into 4 pairs with Professor Chan and Mini Diaocha, right? Professor Chan and Zhangzhi Xingwei, and then Professor Chan and Zhangzhi Shihui Fa, and Professor Chan and Yanzhou Fa, right? So this is actually 4 ties, 4 separate ties. So when you're collecting data, you can either do it like this, right? And then the the first version of the code will accommodate keywords written like as a list, and the second, sorry, and the second script here will accommodate the more direct, properly formatted. So this is the node type 1, node type 2, and these are, each of these is an edge, right? So if a professor only has one keyword, or like here, this professor only has one keyword, then that will just be one tag, right? This professor had two keywords, this professor had two keywords, and so on. So you can see there are a total of 93 ties here. Okay, so that's enough about the data structure and where we're getting the data from. I'm giving you all this background information because part of this assignment will require you, I think in the past you have used my data to do this assignment. For this assignment, you're going to construct your own data set and apply the code to it. So if you have any trouble kind of constructing data in this way, this is actually the more efficient and kind of surefire way to construct the edges. Okay, I'm going to close this. Close this. So let's, but you'll also notice, sorry, one last thing, you'll also notice that the data was all in Chinese, but the nodes were in English, the graphs are in English. So in this script also includes two new things, which I probably should have covered earlier in the course, but better late than never. So we're going to import pandas, regular expressions, import this Pinion package. If you don't have it, you can install it, this. And then we'll import Google Translator, which if you don't have it, you can install with this. So, sorry, I'm that big. Even more than back down. Okay, so with this Pinion package, what we can do, I'm just going to introduce it to you. If you have some Chinese text, like you can generate the Pinyin, you put the Chinese text into this Pinyin translator, and you get and the delimiter here option puts a space between the characters. Right? So there are different variations of this. You can do with the space, without a space. If you use this format script, it will take the tones off the top, just like this, which is nice because this is in simple ASCII encoding, which will open up in any file. This will may give you a little trouble in encoding if you're dealing with like a CSV file and something that doesn't handle this coding scheme with the accents. Okay, you can also have the numerical, the tones numerically. So like third tone. And you can use these other, things to, this is not related to Pinyin. This is just a string function to capitalize all the first letters. So what I'm going to use is this. So I'm just going to strip off the tones. I'm going to I don't need a delimiter. Well, it doesn't matter because I'm going to remove all the white space. Yeah, I should have. And then capitalize it. So, oh yeah, I did this because I want to use the title function first to capitalize the N and the H, and then I remove the white space. Yeah, so actually, this is what I'm going to use in the this is the Pinyin format that I'll use. But we can also look at Google Translate because Google Translate translates, from English to Chinese or from other languages. So you can pick your source language and you can pick a target language, right? I mean, you can have other target languages here. Right? Maybe you want to do a Chinese English to Chinese translator or a Chinese to Korean translator. In any ways, you choose whichever target and source language you want. In this case, we're going to translate from Chinese from traditional Chinese to English. So I'm just creating this translator function where you put in the source language, the target language, and the text that you want to translate, and it will return that translation. So if let's take a Korean word and translate to English. This is Opan Gangnam style, like Gangnam. It translates as Opa Gangnam style. Or if we have Ni Hao, and we'll translate from Chinese to English. This will translate as hello. So this is just introducing the Google Translate, and we'll use this to automate translation of our keywords and professor names. And then between the Pinyin and the Google Translate, we can decide what we want to use later. So, okay, so now let's open up the data. So I'm going to open up the raw data one that have the keywords as a list. I'll read that in. And here's that data. So Professor Chan, here are his 4 research areas. So I'm just showing the first few lines. Okay, we'll have the analysis tab, even though I don't think we're publishing. Okay, so the first thing we need to do is parse these keywords and then create a professor keyword edges for each of these. So here's the list. Here are the keywords, and I'm going to split these. You can see these are all different. I have this. I'm going to use regular expression RE here to split these strings on any of these symbols, right? So these are 3 different types of commas and also a G, right? So you can see here, like, here's a comma, here's one type of comma, here's a different type of comma, and here's G, or sorry, is that G? Yeah. So this character. So you can see here's one keyword, here's another keyword, and here's another keyword. So we want to split on this, kind of treat it like a comma. Check. I'm just curious. Yeah, oh, sorry, G, first one. If there are any other words in here that oh yeah, like you, but see here, I think the U is part of this expression, right? So I don't want to split on this because Shenju Yu Topao Xingwei, this is like one category, right? So I'm not going to split on the U, but I will split on the G. But so you have to, again, this is another reason why it might be easier, it might be cleaner to just to split these and to construct your data set like this, right? So because this here, for example, this keyword should be split, right? So this data set might have missed that one. Anyway, okay, so we're going to split on those. If you find anything else that should be indexed here, like this, in this case, the U is acting like I do want to split these two, right here and here. So it might be better to do it by hand, right? But see, like here, I wouldn't want to split these ones necessarily. So it's very I'm sorry, I didn't go back through and check these very carefully. So in yours, you might want to just go back in and by hand and decide like what's a separate keyword and what's a combined keyword, right? Like this is probably one keyword, not 比较正确 and 民主化 are two separate, but probably not two separate keywords. So anyways, so I'll split those and then remove the white space. Okay, so now if we look at these, right now the keywords are a list. Now again, some of these should have been split. But so I'm treating each of these as a separate keyword. Okay, so now I'm going to create the professor edge key list, which is essentially this. This is the professor keyword key list. Professor keyword edge list. So I'm going to create that and pop all those edges in there, and then print it out. So here's the professor key edge list, right? Which is essentially this. Okay, now we have that. I'm going to go through now and convert each opinion just to see. This is super fast. It does it, very easily. So I created two new columns, professor's opinion and keywords opinion. So we can see if we like that or not. Next, I'm going to use I'm going to create two more columns for professor's English and keywords English or translation. So I've chosen oops, this was let me and target language English. And then I'm going to run these. This line will run the translation, the Google translations of the professor names, and this will run the Google translations of the keywords. I want to warn you that this could take a little time, like not too long, but each of these requests, for each element for each professor name, and for each keyword, we're requesting a translation from the Google website. And so this it can take a little while. So I'm just going to run this and then pause. So I'll run this and then we'll come back when this is done. So resuming recording, you can see it went from 11:46. We started at 11:46. It took about 7 minutes to run those two. So, I think there were only 93 93 rows of professors and 93 rows of keywords. So there was like less than 200 translation requests, and it took like 7 minutes. So I think there's some built-in latency into the Google Translate's website. Like it's free and it's unlimited, but I think they also built in the latency, so you can't just do, millions of requests like constantly. But for us, it's fine. And here you can compare. Here's the Google translation. So obviously for Chinese names, most of the time the translation looks pretty similar to the opinion, and then the English translation. So mini jiacha polls kind of pretty simple. The 政治学, this might be like political science. Like the translations are not exactly perfect. But I would say what you can do is, before you move on to the next script, right, script number 2, if you output this, you can go through these. You can create another column or edit this column, kind of, just clean it up a little bit if you think that the translations are a little bit off. So here's the list. I'll put these as a list. So way, now some of these, most like this one, rigor. Read by John. What is that? Let me look at the. I have a copy of this that I already ran. Right. So, for example, Yan Zhenshan was translated as rigor. Um, that's funny. And also, Long Zigang was translated as cold as game. So there are a few here where, like, the opinion might be better. The Google translation actually tried to look for some. It didn't realize it was a name. I thought it was just a vocabulary word. So, if you're going to use um, the Google translation, you might want to go back in and change some of these. You'll see in the networks that I didn't change them. I just used this column. I was trying to get this out quickly. So obviously, if you're going to do like more polished work, you'd want to go back in and hand alter these or create a new column, copy this column, hand alter them here, or you could go with opinion. So, okay, so I just wanted to show you those results. Okay, and then same thing with the keyword list. Most of these are pretty good. Political behavior, so like here is probably like political and social science or political science and sociology. Not perfect, but contemporary Western thought, political public relations, research methods. These look more like Constitution, government of the Republic of China. These are pretty good. This one is a problem more politically. I think this one is Yijiao Zhengzhi, comparative politics, which should be comparative politics. I didn't change it. I was like doing this very quickly. But if I was going to do this for publication, I would go back and hand alter this to comparative politics. Especially since it's a really big category, I should probably change that. Actually, yeah. Okay, so then professor node list. Here's the node list. Edge list. Just output these. Okay, I'm going to export these to Excel. The node list, the keyword node list, and the professor key node list. The second script, this is the end of the first script. Right? So we end the first script by outputting the professor node list, the keyword node list, and the professor keyword edge list. If you're going to make changes, the professor node list and keyword node list are just for reference. I wouldn't make your changes in here because the second script is going to open up. It's going to only open the professor keyword edge list. So let's actually make the changes here if you want to make some changes by hand. So polls, I'll leave that. I don't like that a lot, but politics, I'll just call this stuff political science. So, but then I need to search anytime it's actually, let me just let me sort by, so make it easier. I'm going to sort by keyword translation, and that way it'll group. Okay. Shao Yitui benefitism? I actually don't know what that is. CCP politics, that's a good translation. This should This should be like electoral behavior. It's interesting. These got translated differently. Shenju Xingwei, Shenju Renshen. Just called it. We'll just leave that. But yeah, I'll call this one management. Funny. Okay, so here to detail juncture, I'm gonna. This is comparative politics. So I'm gonna take that there. Juncture. I'm not really sure. I mean, I'm not going to change too many of these, but okay, yeah. Zhengzhi let's call this political science. Right. So some of these, especially if it's specialized vocabulary, Guohui. And then this Guohui Zhengzhi, I'll call legislative politics. This should be like kind of surveys, popular surveys, opinion polls. I think it was just called these opinion polls. Okay, well, you get the idea, right? So you can go through and change some of these if you want. In terms of names, so I'm going to use this column when I make the network, and I'm going to use this column. But here I'm just going to change these. So let me sort here first. I don't know. Okay, you know, this folded gang, I almost want to leave that because it's so cool. But I'll see. Maybe you know some of these professors. Okay, Chen. I'm gonna just format these a little bit. So we might have gone with an opinion, and I could have put spaces here too. Yes. Okay. Okay. So I'm just going to go with this. So I'm going to use professor's translation and keyword translation as the two columns when I make my networks. So I'll save that. Okay. So now I have, I'm done with this generating the node and edge list. And it's time to go to the second script. Which is bipartite network analysis. So I'm going to go into Jupyter Notebook and open up the second script, which is here. Everything runs slow when I'm recording. Okay, so bipartite network analysis. We're going to have to import several new libraries, which you may not have. So probably you have NumPy, SciPy, Stats. This is our main network library network X as init. If you don't have this, you can use it. You can install it here. We're also just going to use our regular matplotlib plot. I'm setting the font family and font. I'm importing this community detection algorithm for when we do that. Probably we don't need these. I don't think I played with these, but I don't think I included them. So you, by the way, like one of the reasons why I'm translating from Chinese to English is for Python is because matplotlib is not good with foreign language fonts. Like you can play around with it. You can try to get it to read Chinese. You'd need to import like a font file and a bunch of things. So I played around with it for a while and I got frustrated. So I just thought it would be faster to convert everything to English. If you want to plot Chinese networks, you can play with that. Try to get matplotlib to plot Chinese characters. Okay, so we're going to import the data here. I'm importing the professor keyword node list and also the professor keyword edge list. So there are 30 professors in our, there are 30 unique professors and there are 70 unique nodes. And in terms of edges, there are 94 unique professor keyword edges. And use this. I'm actually not going to use the professor node list or the keyword node list. I'm just going to. So once you import this professor key edge list, you can choose. I'm going to let you choose which of these columns you want to use for your edges. So that's where you select it here. So choose your preferred columns. So I'm going to use the professor's translation and keywords translation as my two columns for my two node lists, or yeah, to make my edges. And so here's an so I've limited the edge list now to these. Notice this was a Python, or sorry, this was a pandas data frame, this DF here, and this edge list is not a data frame. It's a list of tuples where each tuple is an edge, right? So for when we're building the network, we do it doesn't accept the data frame as an input structure. It needs a list of tuples. So here's the list structure. And here are this is, each tuple is an edge. So here's the edge list. Here's the full edge list. And then we can get the list of nodes. I'm going to get the list of nodes and the list of edges from this edge list. So I can, here's the list of nodes. And here are the list of, the list of professors, and here's the list of keywords. Right. And again, I got this from the edge list, from this edge list here. I didn't get it from my, I didn't take it from my data frame. So I'm not actually going to use these. So I'm just using the professor key edge list, and that has everything I need. Okay, so now I have those, and now let's make the network. Here's the path for analysis. Okay, so first task is to construct and visualize the professor keyword network. Right, so we're going to use network X. So I'm going to instantiate the graph. I'm going to call that professor key prof key net, and then I'm going to add nodes from the professor key. So here I'm creating remember I'm creating a bipartite network. So I need to add in the nodes, one type of node, and then identify that as one class in the bipartite network, and then add in my another mode or another type of nodes and identify that as a separate class. So I'll add in the professor node list. These are my professor nodes. These are my keyword nodes. That's why I had to create these professor and keyword node lists, right? And once I input those, then I'm going to enter my edge list, right? So, okay, I've added in these two nodes, and now I'm going to add in the edges from the professor keyword edge list. Okay, now we've added in everything. Then I want to separate the nodes by their bipartite attribute. So I'll create bottom nodes and top nodes. The bottom nodes are those where the bipartite class is 0, and the top nodes are the edges, or all of the nodes which don't include the bottom node. So this is some kind of set notation. Okay, now I'm going to add in node level attributes. So I want you to see what node level attributes look like. So remember, I have professor nodes and I have keyword nodes. For my professor nodes, like Taizhongmin, right now this node has one attribute, which is bipartite, and its value is 0 because it's a professor node. Right? And then another node, American politics, that's a keyword node, right? And its bipartite value is 1. So I've encoded the type of node as this variable, or this node attribute bipartite. And we're going to add more attributes onto these as we go along. So for example, if you want to map, ultimately I want to create a map or a graph that ultimately, if I want to make a graph like this, where the professor nodes are blue and the keyword nodes are red, I need to specify those colors. One easy way to do that is to specify the node color as a node attribute. So here, that's what I'm going to do here. So I'm going to define colors for each group. I'm going to create a color map where 0 is blue. Remember, professor is 0, keyword is 1. So professors will be blue and keywords will be red. And then I'm going to create a color map based on the bipartite attribute. So right, so here are the node colors. You can see the professor nodes were entered first. They're all blue, and then the keyword nodes are all red. So then I'm going to attach this. I'm going to set node attributes. So here's the network library. Set node attributes. You have to enter the network, which is my professor key network, and color attributes. So this color attributes is this kind of a dictionary structure that that NX library requires if you want to submit attributes add attributes to the network. So I'll do that. And now if I look at the nodes for Taizhongmin or American politics, you'll see I've added a new attribute. So I've added the color blue to Taizhongmin, and I've added the color red to American politics because it's a keyword. And now I'm going to use these attributes when I visualize the graph. So for the rest of this code, any block of code that looks like this is visualizing a graph. These first variables are all variables that you can change or play with as you modify these graphs. So I've included the plot name. This will also be the name of the file that I output as a PDF. This is the network, or the G for graph here that I'm inputting. You can change the node size. Node colors are actually vector or this list here that I'll use to define the node colors. If I change this to like red, then all of the nodes will be red. But for now, I want to use no color, and then the font size, and then the nodes are. So here for nodes, we have to. I just mentioned this, the professor node list, because when we're doing a bipartite layout, they want to know what's the bipartite class 0, and that will, and then if they know the class 0, then they can know class 1. So this is part of the bipartite layout when you're doing a bipartite graph. So I'm just going to run this. So I'm going to show you the output from several layouts, several network layouts. The first one is this bipartite layout, which is not my favorite, by the way. Here's the bipartite layout, right? And you can see on the left are the professors' names, on the right are the topics. And you can see why I made these font size really small. Like if you could change this to 10 to make the notes bigger, right? It's going to be way too big though. Oh, it's not too bad. Well, yeah, for the left side, it's not too bad, but for the right side, they kind of get crowded. So a lot of this graphing, it's just you playing with these figures until you find the combination that you think looks good. Okay, so this is the 2-mode network bipartite layout. And if you go to your analysis folder now, you can see that it's been output here. It's not the sound. Let me open this real fast. So I output it to PDF because it usually shows network graphs pretty well, whereas like sometimes a PNG file or a JPEG like doesn't always show up as well. You notice that the frame is a little bit too small here. Like if you wanted to widen that, you could go back to here and change these maybe to like 8. Close that. So stop printing. Okay, so there's the window again. Let's see if that made it a bit more readable or fit within the frame. I mean, a little bit. It's still chopping off some of the characters, right? So, but anyways, you can play with these window sizes. You can play with your PDF size, like all this stuff. So, I'm not going to do too much formatting here. Okay, so that's the bipartite layout. Let me show you another layout. Here's the spring layout. So this is a 2-mode network spring layout. Same network, same everything. There are different algorithms, like the spring layout and the Kamada Kawai layout. These are all different algorithms. You can see the spring layout kind of tries to separate them. You can also see there are several components. We call these network components. I'm just gonna network components, right? And this is the largest component, and then these are all smaller components, right? Components mean like connected, self-connected parts of the network. If you have more than one component, like you have your largest component, but then you have all these small ones, some of the network measures, like centrality measures, will not work on and this is an unconnected graph, because, for example, like degree centrality you can calculate, but so like between the centrality would be it's impossible because there is no path from, like, say, this node from this component over here to this component over here. There's no pathway, and so that actually breaks some of the centrality measures, like betweenness or eigenvector centrality. So that could be a problem for network analysis. We'll talk about different ways to address that. But anyways, let me show you one more layout. This is the Kamada-Kawai layout, which is similar to the Spring one, but tends to pack them together a little better for smaller networks. You can see each of these being output. So you've got the Spring layout, Bipartite, Kamada-Kawai. These are all the two-mode blue-red networks. So here's Kamada-Kawai, right? Packs it a little bit better than the Spring, I think. But you still have these multiple components. So for this analysis, what we're actually gonna do is we're gonna cut out these smaller components, and we're just gonna focus on the larger component. And that's a little bit problematic, right? Because that means we're gonna lose these people. We're gonna lose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 professors, right? And we're only gonna focus on this central group, which is connected. Right? It means that if you're in a component over here, it means that you're kind of by yourself or in a small group, right? Like Wang Yanjing does Constitution, International Law, Human Rights Law, but nobody else does those in his department. Here it's hard to see. Zhang Qishen does Chinese political thought. Nobody else does that. Here somebody does. Dong Guozhen does Western diplomatic history. And so part of this might be just a feature of the way that they define the keywords. Maybe their keywords are actually connected to some of these keywords, conceptually, but if the keyword itself is not connected, they will appear as this peripheral smaller component. So I think, there's some ways that we can deal with that, but for now, the simplest way, we're just going to cut these smaller components out, and we're just going to isolate this large component. So to get components, you can get connected components using the network library on our network. So I'll list all of these, and you can see this is one component. Here's another component. Right, these are obviously like smaller components, right? This is one small component, Here's one, right? This is our very large component. This is the biggest component here. Here's a small component. So, oops. Right, so you can see all the components here. I'm gonna get the maximum based on the length. So the largest component is this one. And I'm going to create a new network using the old network and taking a subgraph using the largest component. So here, and you can see Taizhongmin and American politics. I'm checking the nodes are still in that central component. If we go back, can we find he's in here somewhere. American, do we see American politics anywhere? Let's see if the PDF is any better. This, we can zoom in, do we see? Do we see American politics anywhere? Should be in this large component somewhere. Maybe I'm. Is this it? American politics. You can see it. It's so hard to see. That's why I don't mean might be one of these. American politics. Oh, maybe here. Yes, I don't mean in American politics. It's so hard to see because, and that's one reason why we're going to go to this larger component, because these small components make it really hard to see the whole graph. So, okay, so if I use the largest, you can verify what's the largest component. I already did this. And so I'm going to isolate the color nodes, the node colors for the largest component as well. And then I'm going to do the Kamada Kawai layout again. Okay, so you can see this is the same. This component here is the same as this large component here, right? But now we've isolated it. And now you can see much better. Here's Taizhou mean, right in the middle there. Comparative politics, gender, political research, Chinese research, right? Where's American politics? American politics, right? It's over here. So this is the larger component, and I've output that here as well. Two-mode network, largest component. All right, so let's keep going. Okay, so we have the largest component of the bipartite network. Now we're going to do projections. So network projection of bipartite networks means you can take your node 1, node 2 network, which is this, right? And you can project it into node 1, right, which is professors. You can professor network, or you can project it into node 2, which are keywords, right? This is a node 2 network and a node 1 network. So what do I mean by that? We're going to do keywords. So we're going to do keywords first. Notice here, comparative politics and Latin American politics, right? Now, because this is a bipartite network, you can't have these two connected to each other. But you'll notice that both of these nodes are connected to the same professor. They have at least one professor who is connected to both. This Sui Yanbin does comparative politics and Latin American politics. So if we do a projection of the bipartite network into the keyword network, if we just want to see a network of connections between keywords, we're going to define edges between keywords as any two keywords that have at least one professor in common, right? So in a keyword network, comparative politics would be connected to Latin American politics because they share a professor, right? Political behavior would be connected to political and social because they share this professor, right? Research methods would be connected to elections because they share this professor. So that's what a projection is. We can project this two modes network into a single mode. And we're going to do this twice. We'll do this once for keywords, right? So comparative politics is connected to Latin American politics, and we'll do it for two professors. So for example, Sui Yanbin is connected to Qianyi Chun because they both do comparative politics, right? And so we're going to look at the projections into the keyword network and the projections into the professor network and see what we can learn from those. And to be honest, I think the projections into the keyword and professor networks are actually more insightful than the bipartite. The bipartite network kind of looks cool, but in terms of insights, the projections offer, I think, a lot more insights. So we're going to do two things. We're going to project. Well, first we'll project into the keyword network And then we're going to do two different types of analysis. We'll do centrality measures of the keyword nodes, and we'll cluster the network. So I'll show you how to do those two things. So here, so our largest component has 51 nodes overall. I changed this. This would be nodes. This number may change a little bit because I edited the keyword names in the raw data. Okay, here are the original keywords. I can check if American politics is in my key node list or professor node list. American politics is in the key node list. It's not in the professor node list. Is it in the largest node component? Yes. These are just some operations you can run, on nodes in the network list. Okay, so I want to get a list of the keyword nodes which are contained in the largest component. So to do that, this is the keyword node list in the largest component. To do that, I'm gonna take all the nodes in the largest component, and I'm gonna subtract all the professor nodes. So whatever's left in this largest component will only be the keyword nodes from the largest component. Right? So there are 35 of those. And now I'm gonna use this abridged list of keywords nodes to create a bipartite projected graph, right? So this is taking the largest component, and it's going to do a projected graph on the keyword nodes in that graph. Okay, and now let's do the commodified layout on the keyword network. And I'm just going to color these nodes red because it's not a bipartite network anymore. It's going to be a single mode, a one mode network, only on keywords, right? And so we've been using red to color keywords. So we'll call this the keyword network. And here's the keyword network. So elections are connected to public opinion and democracy, right? Political economy. Oops, this is the uppercase and lowercase. I should have fixed that. That should be the same. Oops. European Union is connected to European government. So here you have a European cluster. Here you have some global politics, mainland China. Here you have public opinion polling or public opinion and legislative behavior. Here you have international politics, right? International and American and African politics. This is more of a comparative politics cluster. Here you have some social welfare, gender, and congressional research. Immigration policy, right? This is more kind of social policy cluster. And what's in the middle? What's in the middle of this, of the department? You see political methodology, political behavior, research methods. This is kind of your methodology core with some comparative politics. I'd say methodology and comparative politics are really at the core of this department. And then you have these European, this legislative, and some mainland politics and global economy, right? Political economy, and then this policy, welfare policy cluster. So this really gives you a sense of topically, like how this department is constructed. Right? I find this very insightful. Right? This tells me a lot about what this department is really like. What are people in this department studying? You have a couple of outgroups, and then you have this kind of core that holds it, that's at the center of the department, which is, comparative politics and research methodology. So let's do some degree centrality of the keywords. So I'm going to use on this keyword network. I define this as keyword network. And remember, this is just the largest component. Remember, there were several keywords like Chinese political thought, CCP politics, Western diplomatic history. There were other clusters out there, international development. These keywords were out there as well. These were also clusters, but they were not connected to the main network. So these are, remember, these are also part of the department, like big data, but they're not connected to the main component. So they won't be included in this analysis. So the degree centrality, we'll run the degree centrality on that network. And this gives you the degree centrality for each. This is a weighted degree centrality on each for each keyword, and we can sort these from highest to lowest. So here's comparative politics is the highest degree centrality. Opinion polls are second. Political science is third. Research methods, political behavior, and voting, political methodology. So you can tell, like, again, these are in the core of the network. They have the highest degree centrality. They're at the center of the most popular topics. Less popular topics, right? Mainland, in China, political economy, political public relations. Some of these are more combinations or more esoteric. Congress, research, African politics, welfare country, welfare state. So these are less popular topics. These are the very core kind of popular topics in the department. If we attach, so I'm going to attach this degree centrality as a node attribute. And now you can see it's bipartite, the color, and the degree centrality. I'm going to create a new, now I'm going to use this degree centrality to actually weight the size of the node. So to visualize these nodes, so nodes with larger degree centrality, I want to appear bigger. So I have a kind of multiplier here. This is very arbitrary, like you can choose whatever you want to visualize this. So I'm going to basically just multiply the degree centrality by 1,000 in this case. So these are the new node sizes. And if I'm going to show these in the keyword network for degree centrality, and the node size is going to be this keyword degree. So you can see the nodes now will appear larger, smaller. So right here in the middle, you can see comparative politics, opinion polls, political science, research methods. These are the big, most popular ones. And then you have, smaller nodes out on the periphery. Gender is like relatively big in this cluster, right? American politics is big in this cluster. So this just shows kind of, it weights you could change this, right? If you want to weight it a little bit more. Right, you can, I think it must moderate the weight something because they can't make them like too big. But one thing you'll notice is each time you run the algorithm, the structure, the topology of the graph, or at least its layout, it changes every time, right? So it's not always oriented the same way. The edges and the nodes are the same, but sometimes the orientation will change or turn, which is good because you don't want your intuition about the network to be tied to any particular orientation of the network. Okay, let's calculate the betweenness centrality. So take the same keyword network and here's the betweenness centrality and sort those. So again, in this network, the most popular topics in the center, which have the highest degree centrality, also have the highest betweenness centrality because they're in the center, and you have different. They're also connected to these outgroups. that's what's going to give them high between the centrality, because to move from one outgroup to another outgroup, you have to go through the center. So these have, so between this, yeah. So, and we can attach these attributes. You see between the centrality has been added. I'm gonna weight the nodes and plot another keyword network with between the centrality. And here you can see, again, nodes at these junctures between larger cluster and smaller clusters are going to have high between the centrality, because any paths from one side of the network going to this other side of the network, right, or to this cluster up here, they have to go through comparative politics. Same thing with political science here. Everything here has to, anything connected here to here has to go through these key kind of broker nodes. So in this case, what you'll notice is opinion polls have high degree centrality, but it doesn't have as high between the centrality because it's not at one of these key choke points, right? Like comparative politics or political science. So it's not a one-to-one relationship, but I do want to show you that the correlation, if we can calculate the correlation between degree centrality and between the centrality, we'll run a Pearson coefficient on this. And the correlation between degree and between the centrality is almost, it's very close to 1, right? I mean, 0.9 is very high. So in this graph, degree centrality and between the centrality are highly correlated. And that's just a feature of the network structure. Okay, so I'm going to cluster these. This is the last thing. I want to cluster these. I'm going to use this von Neumann community detection, which is essentially hierarchical clustering, which we learned earlier. So I'm going to cluster these. You can see here in this algorithm, you can choose the number of communities that you want. So let's start with 2 communities. If you just choose 2 communities, you can see here, we'll create a color map like this. I'm going to grab the colors from the color map and assign those as node level layers, or sorry, node attributes, and then plot communities. So this is going to cluster, and it's going to show you, if you go with 2 communities, this is how the 2 communities would be divided, right? You've got your basically your comparative politics core over here, you've got your methodology core over here, but I don't think 2 clusters is really capturing the structure of this network. So I'm going to go back up, can change it to, let's try 3. And plot it. So I'll let you play with this. Here, one. So I still don't like how, I mean, the comparative politics is still kind of capturing this part, and then you've got mainland politics stuff over here, and you've got methodology, but then this other cluster up here is not really part of this methodology. So I'm going to go with 4 clusters. You can play around with this. I'm not going to tell you in this class. I mean, there are metrics to tell you like what's the best number of clusters. I'm not going to cover that in this tutorial. This is not bad, right? So this cluster captures this public opinion and polling, which is actually probably the election studies center people. Here you've got the comparative politics, which reaches over to welfare policy, which is, I think, a fair. That's a nice topical linkage between those. It's very qualitative policy analysis. Here you've got your methodology group, right, which is legislative politics. This is most of your quantitative methodology, research methods, opinion polls, and then you've got the mainland China political economy group. I think if you did 5 clusters, this would probably be a separate one. So let's try that. Maybe 5 clusters works best. Yeah, see, and that 5 cluster is just it's gonna break off that. Here's the opinion polling, the elections opinion polling. Here's the that European group. This is a separate one, right? Here's your comparative politics and your methodology. So you can decide however many you want. I guess I'll go with 4 clusters for now. Doesn't really matter. You know, and again, because this is an unsupervised method, so these clusters are not labeled. So if you want to, I'll give you the community labels here. You can print this out. So you can see community 0, right? These are community 0. These are the keywords in that community. And then for community 1, these are the keywords in community 1. You can use these if you want to label these clusters, right? So cluster 0, you can give that a label. Cluster 1, you can give that a label. Cluster 2, 3, you can give those labels, right? If you like. So this is clustering of the keyword network, and that's saved. Let's see. I've saved that here as keyword network. For each number of communities, I'll put a different graph. So you can see, you know, you can look at these like more carefully. So this is 2 clusters, 3 clusters, 4 clusters, 5 clusters, and decide which one you want to go with. And once you choose one of these, say you go with like 4 clusters, then you might want to, like I said, you might want to label those and create like a little legend, you know, in your graph here to identify what's this pink cluster, what's this orange one, what's this green one, what's this blue one. So quick note on colors. You can go here because this is Matplotlib, and there are a lot of color maps that you can use. I'm using dark 2. You could use, you know, you can pick different color maps if you want to try different coloring schemes. You know, you can play around with that. If you go to this website, you'll see, you know, dozens of color maps. Some of them are better than others. Just make sure that you choose colors. These are qualitative color maps, which mean, you know, distinct palettes of like separate. Other quantitative color maps are like rasters, where it's like a spectrum or from it like merges from one color to another kind of over continuously. But when you're coloring like classes or categories, you want to use a qualitative color map. So just make sure that if you choose a color map, make sure it's a qualitative one, not a, I don't think they call it quantitative, but anyway, you can look on their website and check that out. Choose whatever you like. Okay. Yeah. You can also see the colors here. That's not going to help you that much, but these are basically the RGB values for the four groups, because here we have 4 clusters. So that's not very helpful. Okay. So I'm going to speed up this tutorial. Like I've done that keyword part. Now I'm going to show I'm going to do the same thing for professors now. This is basically the same code, but now I'm taking the largest component and subtracting keyword nodes so that I'm left with professor nodes. And I'm going to build, these are the professors in the largest component. And I'm going to use this to build the professor projection. And I'm coloring these blue. Yeah. You can see those are here. Now remember, there are a lot of professors that I kind of excluded. So in your overall analysis, you'll want to mention that there are these outliers, that is the peripheral smaller clusters, right? But in terms of the network analysis, we're just going to look at the professors connected in the largest component. You can do the degree centrality for these, right? So in this in the department, Liu Yizhou is the most connected, which makes sense because that guy's been around forever. Su Yanbin, Fang Ji, these are highly connected individuals in the network. If you go back and look at the two-mode network, let's look at the where did they fall in the network? So if you want to see that, let's look at the largest component. Let's find Liu Yizhou. Liu Yizhou is right here. So why does he have such high degree centrality? Well, he has, first of all, he has high between the centrality between the Selection Studies Center people, like Sheng Yu and Yu Xiuqiong, right? So he's connected to those people. He's also connected to this European, political science. He's also connected to the research methods and opinion polls. I think the fact that he's in the Election Studies Center and he's also very active in the department, so or at least he's tied into research methods and opinion polling, which connects a lot of other professors. So that's maybe why he has such a high degree centrality. Who else? We can look at who else has high degree centrality. Su Yanbin. So if you look at, let's find, oops. Su Yanbin. So Su Yanbin, on the opposite end of the network of the core is Liu Yizhou. Su Yanbin is connected to comparative politics. So anybody who's doing comparative politics and also political behavior, a few people. So that's why, Su Yanbin he has this kind of topical area and also this methodological connection, which are connected. Here's two professors over here, and through comparative politics, he's connected to 1, 2, 3, 4 people over here, and that's Zhangmi and Chen Yong. They all do comparative politics. So Su Yanbin has high degree centrality because of his connection to comparative politics and political behavior. And who else? Let's look at one more. Fang Ji, also very high. Fang Ji, again, Fang Ji, yeah. So Fang Ji also, like Su Yanbin, connected to comparative politics, but also connected to voting and political methodology. So again, people with these, in this case, these people with high degrees between the centrality are connected to, they're connected to topics which have high betweenness and degree centrality, right? So because Fang Ji is connected to comparative politics and political methodology, right, which are very high degree topics, that connects them to a lot of other professors, right? Okay, so that's kind of how I would use this two-mode network if you want to analyze, where in the network, where in the department to particular individuals or particular topics, how do they connect to different groups of people? So that's the professor network, the degree centrality. You'll notice that we can size the nodes and plot this. Right. Notice that everybody in the center here who's doing methodology though has pretty high degree centrality. It's only people who are out kind of in the periphery who are not connected to these kind of core comparative politics and methodology folks who have smaller degree centrality. Right? And then between the centrality, again, it's going to be pretty highly correlated. I'll show you the graph. Well, you can see here, again, the people who had high degree centrality also have high between the centrality. Fang Ji, Su Yanbin, Liu Yizhou. If you look at the graph, it's a bit more pronounced, right? There's Liu Yizhou, there's Fang Ji and Su Yanbin and Chen Xiang, right? So, okay. I should say again, these numbers and everything is contingent on like so a lot of these keywords could be overlapping or very similar, and that might change the structure of the network, right? So for example, like political economy with a lowercase p and political economy with a uppercase p should be connected, and that could really change the network structure. So you'll want to go back through here and make sure that similar keywords are coded exactly the same way, right? So you don't get like it doesn't throw off your network structure. Where's the other part? Economy with a capital P. Maybe it's in maybe it was out, maybe it was one of the peripheral nodes that got cut. Okay. Okay, so the correlation between keyword and between centrality here is also pretty high, right? The between the centrality and degree centrality of professor network. If we do the clustering, I'm going to go with 4 clusters again. You could build it up 2, 3, 4 clusters. Here's so Yang Waning is her own cluster here. You've got this is the comparative politics cluster, this is the methodology cluster, and you've got the election studies center folks up here, I believe. So this is actually not too bad. I think if we did 3 clusters, probably Yang Waning would be included in this. We can try that. You can play around with it. Again, the network structure is a little bit sensitive to oh, no, it still left here as well. This is separate, so let's go with 4 because I do want to capture that difference between the comparative politics and the methodology people. Quantitative methods. Yeah, so I think this division is particularly interesting. Right? You have the methodology people, election polling methodology people, and the comparative politics people. Of course, there is still overlap in them, but it's interesting that it captures that. Okay, so and then you can see the labels for each community, right? So this community one, this is the methodology component with the OHO. Here's the comparative politics cluster. Here's probably the election studies center people and Yang Waning. And again, remember, like in your write-up, you'll have to also comment on these other outlying groups, right? You'll want to mention them as well. So, okay, I'm going to stop the tutorial here. I've covered the basics of how to build up your edge list, right, for your bipartite network, and 2 different ways how to do that. And then I've covered, some of the basic like analysis you can do with the bipartite network. We've talked about how to construct that edge list, how to project, how to display the professor keyword network, right? How to add in the nodes and edges for that, and color the nodes, and to visualize that. We've talked about different types of graph layouts. We've talked about components, the largest component, isolating the largest component and visualizing that. We've talked about projections into single nodes, like the keyword network or professor network. We've talked about degree centrality and between the centrality, and we've talked about clustering. So these are all tools that you can employ in your analysis. I will include another tutorial, I think, after this to explain the assignment a little bit better. but basically, you know, I want you to construct your own network, and run the analysis, you know, basically run through the similar analysis and kind of comment on the network structure, on, you know, on the keywords, on the professors, you know, what do the centrality measures mean, like highlight some of the high degree, high centrality, highly central professors, highly central keywords, comment on the community structure, you know, and it's kind of summarize, like taking all these bits and pieces of information, you know, and images of the graphs and centrality measure tables and things like this to construct kind of a profile for whatever department you're looking at. I'm not sure for the assignment, you can pick a department and do professor keyword network. If you want to do something else, I'm also open to that, right? It just needs to be a 2-mode network. And also in the next tutorial, I'll do a kind of a follow-up on cleaning up these keywords. I have an idea to use like word embedding models to find distances between keywords. So say you have 2 keywords which are quite similar. In this network, they're treated as totally separate. But you know, maybe political economy and you know, politics and economy, for example, should be much treated more similarly or closely. So that's a very advanced application. So I'll show you that in the next tutorial and see if that changes the network structure at all, but it won't be part of this assignment. So, okay, so yeah, good luck with this, and then keep your eye out for the next tutorial.